AADL modeling revolves around the notion of components. There are three types of components in AADL: software, hardware, and composite. A good example of a software component would be a process or a thread in which a program is executing. A hardware component can be a processor or a memory on which the program is stored, or an external device which provides input or performs a function such as a video camera. A composite type may include both hardware and software components. There is one aspect about how components are defined in AADL which is very important to remember. A component definition consists of two parts: a component type and a component implementation. A component type is how a component can be seen externally as part of another component, for example. A component implementation is an internal structure of a component, which can include its subcomponents. Let's try to work this out in an example. We need to build a simple security system installed in a store. The system consists of a system unit, which contains software, a processor, and a memory. The system unit receives input from a motion detection device and a magnetic alarm sensor installed in a window. When motion is detected or a window is opened, the system unit sends one signal to a video camera which starts recording, and another signal to activate an alarm unit which consists of a sound and a light alarm. Pause the video here to make sure that you understand the description and requirements of the system. Let's do this in OSAID 2. Create a new AADL project, give it a name, and click Finish. In the project, create a new AADL model. You will see that OSAID creates a package for our model, and we will start adding our system's components between the public keyword and the end of the package. It is always a good practice to start your modeling with a top-level definition of the system. If you remember from the requirements, the system we are developing will have both software and hardware components. So if we think of our entire system as a component, in AADL it will be a composite component, called system. As you also remember, the component consists of a component type and a component implementation. Here is how they are specified in AADL. Add the component type, system, and give it a name, security system. Then specify its particular implementation by attaching it to the security system component type and giving it its own name. Let's say security system with devices. It is impossible to specify an implementation without a component type. However, a type may have several implementations. Just like we added the system, we can now add the devices that the system consists of. Let's add the motion detection device. Again, we will add the type and the implementation. In the same manner, let's add the remaining devices: the magnetic alarm sensor, camera, and alarm unit. Now that we have defined our system and 4 devices, we can place those 4 devices inside the system. As we know, the internal structure of the component must be defined inside of its implementation. So we'll add the 4 devices inside the security system implementation. Use the keyword subcomponents in the security system implementation, then add each component by giving it an inside name, a name by which we will refer to it inside of this particular implementation, then specify its type and the name by which it is referred to outside of the implementation. All these devices had to have their types added to the model before they were added as subcomponents of our system. You'll get an error if you try to add a subcomponent whose type has not been defined yet. If you have models in several packages, you can add a component of a particular package by specifying its name and placing the name of the component after a double colon. The component, however, has to be public. You can also view and edit this through the AXL file, which is generated from our AADL model. Or you can view the model graphically if you have the IMV plugin installed. Next time we will talk about adding ports to establish communication between the devices.